So second program. So let us see what is the second program here. So you can see from the list of the programs which are got. So the second program tells that you have to write a program to find the sum of first 10 integers. So I think this I have already explained. Again, I will explain. That's not an issue. Okay. So the second program tells is so you have to write a program to find the sum of first 10 integers. Is the program title what it is supposed to tell. Okay. So now here, so the program is so you have to write the program to find the sum of first 10 integers. Okay, first 10 integers. So this is the program which you are supposed to start with. Okay, so when you are starting with this particular program, so now we have to find the first 10 integers. Okay, so if we take the first 10 integers, it is nothing but what? So if we take this particular example, it will be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Okay, so this is the sum of first 10 numbers which we need to find for the first 10 integers according to the program title. Okay, so now if you add this number, so it's a so the formula which you can use is n into n plus 1 by 2. So where n is 10, n into 11 by 2, which will be equal to 5 into 11, which will be 55. Now whatever the value you are going to get 55, so that will be converted to hexadecimal value. So that will be 16 3s of 48, 48, 48, and it will be 7. So the hexadecimal equivalent of 55 is this is the hexadecimal value which you are going to get. So 37 will be the hexadecimal value for sum of first 10 integers. So this is the hexadecimal value for sum of first 10 integers. Okay, sum of first 10 integers. Now, when you are going to have this one, so we have to write a program to find the sum of first 10 integers. So now here, when you are, I'm just explaining the concept with respect to the C program, as I told you already. So the program which you are going to write, so it will be in, if you write the program in the language which you know. So then it will become easy for you to write the language in your assembly code. So you go that particular fashion. So it is not mandatory that you have to follow the program what I'm going to teach you in the class. So unless and otherwise you get the proper output, you can follow any type of program which you require. That is how we are going to understand that particular logic. Because if you take this logic when you're writing a program, so different people will write in different form of different programs. Okay, that is left to an individual. So when you are writing the program in different fashion, that is left to you. Unless and otherwise, you have to get the proper answer. That's it. Okay. So now here in this particular thing, so now first I need the counter. So here if I go with the C program, for example, so first I am going to have the initialize your header file. So that is your main. So as I told you, the same way you follow it. That's it, nothing else. So like you are going to have the main program. So as I told you that this particular program, you use it using do while. So then it will become easy for you. So if you're going with the while means one more instruction will come, even it will work. Unless and otherwise you know what are the corresponding instructions you have to use from your ARM instruction, ARM assembly program. So if you know complete set of instruction set, then it will become easy for you to understand, write the efficient programming in your ARM. That's it, nothing else. So now if you go with the int main program, first I need the counter. So I am going to declare 3 variables. So here in your assembly code, what will happen? We are not declaring any variables. So here it is only, we are going to play only with respect to the registers. So we are going to have only the registers. But in your C program, we are going to have the variables. So where we are going to make use of the variables and we are going to use that particular variables to execute the program. Okay. So similarly, for example, I am going to write that here. So I am going to use the register R1, R2, and R3. So just for your understanding sake, I'm telling. So now, where your R1, I'm initialize for counter. So your R1, I'm using it for counter. So I want to count for 10 numbers. So I want the counter. So for that one, I am initializing my counter. So the counter will be 10. So 10 times I have to repeat the counter. So I have to calculate the first 10 integers. I require the counter for that one. So from 10 to 0, I'm going to use it. So if I'm going with 1 to 10 and I have to make use of the compare instruction at the time. So then, so it is left to you now how you are going to write the program. So I am going to write in this fashion. So that is next is that is left to you that whether you are going to increment the counter if you are using the for loop type or while loop type or do while type. So I have explained that concept. So if you are going with the for loop, what will happen? If you go with the while loop, how many instructions it is going to get? If you go with the do while loop, how many instructions you are going to get? So normally I am going the procedure of do while loop. Okay. So then I'm going to initialize my first number. So that will be stored in the register R1. Okay. R2 is going to store the initial first number. Okay. So the first number is 1. I'm going to have because I want to add 10 numbers. The first number from where I have to start is 1. So this first starting number 1, I'm initializing it to where the register R2. So in your assembly code, the same naming convention I'm used here for your understanding purpose. In which registers I am going to use those numbers. Now I'm going to have the sum. Okay. Next I am going to have the sum. So the sum I'm going to store it in R3. Okay. So this is the sum. I'm initially I'm going to initialize my sum to be 0. So I will consider that I have not started anything. So I have to start from 1. So I need my sum initializing my sum to 0. So next your do while loop start. So do while is nothing but what? It will be having some address, right? So if you take any program in assembly, in your high level language, all these are nothing but the statements. Okay, that you keep in mind. When it is converting from high level language to low level language, so all your high level statements which are there, it will be converted to the assembly language statement. So in your microprocessor, when you are writing your C program, so that will be converted to 8086 program. Okay, that will be converted to 8086 program. Okay, so that is the nomenclature which they are going to use for your Pentium processor i8 is 8086. So that is the higher version of 8086. So whatever the assembly instruction, assembly code you are going to get, that will be in 8086 format. So now that if those who are using the Linux or those who are proficiency in Linux, they will be knowing that one, how to convert that particular code to assembly code. So if you have the Linux for your only for your knowledge purpose, so if you take cc -s 1.c, so this is the command which you need to use for to convert your 1.c to 1.s. Okay, 1.s it is going to come. So where the .NET specifies it is the assembly code, and you can open that particular code and you can see it how it is going to look like. So that is left to your knowledge how we are going to go and how we are going to look into this one assembly code. Next, in the do while loop, what I need to do first I need to add the first number with second number. I am initially I am going to add the sum with the contents of R2, the first number. So my initial sum is 0. Okay, and the first number is R2. So I'm going to add these two numbers and I'm going to finally load that particular value into R3. Okay, so that means what? Your R3 will be equal to what? R2 plus R3. R3 will be equal to R3 plus R2 plus R3. So now next statement, what I need to do? Can anyone tell? What I need to increment now? I have to add the previous number. First number I have added with 1. The next number I have to add with 2. So if I add with the 2, what I need to increment? What value I need to increment?
2.
2. So that means which register is holding now here in this one? It is R2. So I have to increment. R2 will be equal to R2 plus 1. Okay, that is one statement I have to use. Now I have to keep track of the counter. So counter is tracking by which register? Counter is tracking by your register R1. So I'm going to decrement the counters by 1. So your R1 will be equal to R1 minus 1. R1 will be equal to R1 minus 1. Now till where I am going to use this one? Till your R1 is greater than 0. So till your R1 equals 0 or it is greater than 1, I need to continue it. While R1 is equal to 0, I have to terminate that particular loop. Or R1 till R1 is greater than 0, I am going to terminate that particular loop. So when R1 equals 0, that loop will terminate. So at that time, the condition goes false, it will come out of the loop. So any doubt in this particular program now? Anybody having any doubt? In your C code, if anybody having any doubt? Anybody having any doubt?
Sir, explain once R3 condition, sir.
See, your R3 is nothing but what? It's a sum. R3 is holding the sum. Initially, before entering the loop, my initial sum is what? The initial sum I have to initialize to how much? 0. The initial sum I have to initialize to 0, right? Understood? Initially, before entering the loop. Before entering the loop, I will assume that my sum is 0. Understood? Hello?
Sir.
Okay, now I am going to add your present sum which is there with the first number. Where is the first number is stored? In the register R2. So that I will add. R3 will be equal to R2 plus R3. So I'm going to add the sum, which is previous sum, which is 0. So in the first iteration, what will happen? Your R3 is 0, iteration 1. If you take the iteration 1, your R3 is 0. So if you take R3 plus R2. So what is the value of R2? 1 in the iteration 1, first iteration. So the new sum will be equal to what now? Now the new sum will be equal to 1. So where it will be stored? In R3. Any doubt? Anybody having any doubt?
No, sir.
Now, after having the sum, your new sum is 1, which is stored in the variable R3. So your new sum is 1, which is stored in the register R3 here. So next in the iteration 2, and then it check for the condition R1 is equal to R1 minus 1. So now R1 becomes what here now? So your R1, if you take R1 becomes 9 now. R1 is R1 minus 1. Initially R1 is 10. 10 minus 1, it will become 9. So whether it will, while R1 is greater than 0, R1 is 9, it is greater than 0. So if it is greater than 0, again, the flow comes into the do while loop, right? So the flow comes inside the do while loop. Again, it will start executing R3 is equal to R2 plus R3. What was the previous value of R3? What's the previous value of R3? Your previous value of R3 is 1 plus what was the previous value of R2 now? R2 I have incremented to 2 here. So that will become 2 now. So that's your sum will become 3 in the iteration 2. Any doubt? Anybody having any doubt?
No, sir.
Okay. So next in the iteration 3. If you take the iteration 3, what will be the value of sum R3? What will be the value of sum R3?
3.
3 plus what is the next number which will be holding in R2? It is 3. So that will become 6 in the iteration 3. And your, if you take this, if I take the value of your R1 into consideration here, just I will make a small space here. So if you take the value of R1, so here initially when the counter becomes 0, it will become 9 here R1, it will become 8 here now. So in the iteration 2, so your R3 is 6, the next number which you are going to have is 4. Your R3, after adding it, it will become 10, it will become 7. So this process continues till where? This process continues till your what? Till your R1 becomes 0. Till it R1 becomes 0, this particular process will be continued. Right? Anybody having any doubt? So similarly,
Yes,
iteration. So iteration 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be 10 plus 5, 15. It is going to have here. It is 15 plus 6, 21, and 21 plus 7, 28, and 28 plus 8, 36, 36 plus 9, 45, and here 45 plus 10, it will be 55. So in the 10 iteration, it's going to have the value of R1 become 6 here, 7 year, 6 year, 5 year, 4 year, 3 year, 2 year, 1 year. After this particular iteration, the R1 becomes 0. So now here this condition fails here. Your R1 is equal to 0. So the loop disconnects. So the loop terminates here when R1 becomes 0. So this is the logic what we are going to use in your program. Anybody having any doubt? Anybody having any doubt? Anybody
No,
having
sir.
any doubt? Okay. So now, if I write the same code in your assembly code, so now you have to tell that what are the corresponding instructions I have to use now. So this part I will delete it. So now here in the beginning, what I need to use, I have to make use of area. What I am going to find? So I am going to find the sum of 10 integers. So that part of the thing is code only. Then it is read only. Anybody having any doubt? Anybody having any doubt? This is a normal structure of the C code, of your assembly code, which you are going to have. Area, sum of 10 numbers, that is a name of the program which you are going to have, followed by what is that particular part of the code is code memory. What type of memory you are going to use? It is a code memory which you are going to use. So area, so that should be in. So then I'm going to have the sum code, then read only. Read only. Okay. So next, after that fun, you're going to have the entry point into the program, which is nothing but your flower braces is the entry point, and it's going to be started from some starting address. Okay. So now this particular part is not required in your assembly code. A direct initialization I have to do, right? Because I am using the variables, I require the variables in C code. But here I don't require any C code. So I'm going to make use of my register move R1 comma hash 10. So what is going to move? It is going to move the 10 counter. It is going to initialize the counter into the register R1. Okay. So that means R1 is used as a counter. What value it is going to store? It is going to store 10 because I have to calculate first 10 integers. So next, what value I have to move to the R2? What's the value I have to move to the R2? What value I have to move to the R2?
1, sir.
1. Yeah. Next, what is the instruction? Next, I have to initialize my sum to 0. Who is holding the value 0? Which register I am using?
R3.
R3.
Okay. So R3 I am using to register to 0. Next, your loop starts here. Wherever the loop starts here, I should have label, right? So I will press the label. Okay, label is nothing but some address where the control has to go back. So now, once your address starts, so what is the instruction I have to use here now? What operation I am performing? I am performing R3 is equal to R2 plus R3. What is the instruction I have to use here? What is the instruction?
Add.
Add. What content I have to add? I have to add the contents of R2 and R3, and I have to store the result in R3.
R3.
Okay, next. What instruction?
Add.
Add again. What I need to add?
R2.
R2.
R2
And
comma
one.
R2. Okay. So next,
Slash 1.
I have to decrement the contents of register R1. So I am using the condition code here. I have to set the flag. To set the flag, what I need to have the suffix for my subtraction instruction? What I should present if I want to update the flags along with the subtraction, what I need to use? Sub?
Yes. Subject.
Yes. Yeah. If I am using the sub S, After the execution of that particular instruction, the corresponding flags will get updated. So it will be R1 comma #1. So that is going to be decremented the contents of your R1 by 1. So now, if it is not equal to 0, if your 0 flag is not set, okay, in the iteration what will happen? Your R1 will become 9. Whether it is equal to 0? No. So if it is not equal to 0, where the control flow has to go? If it is not equal to 0, if your R1 is not equal to 0, where the control flow has to go? What operation again it has to perform? What operation again it has to perform? Again you have to start with next. This is the label, right? So to that particular label I have to go. Branch are not equal to next. Any doubt? Anybody having any doubt? Anybody having any doubt? Anybody having any doubt? Yes or no? That's it. Yes means yes, no means no.
No, sir.
Okay. So next I am going to have some infinite loop of type of operation, halt B alt. So that is unconditional branch. So B is unconditional branch where I am going to have the unconditionally branching to the halt. Where the alt is there, here. So the loop will be continuously repeating. Okay, it will stop here itself and it will not go further. So at the end of the program, you have the statement end. Okay, so this is how the code will work for your second program. That is to when you are calculating the sum of first 10 integers. Okay, so now if you are using your online browser, okay, I'm going to make use of the online browser which you are going to have. You will type this particular code here. So only limitation in your ARM browser is it will be working as an interpreter. It won't be working as a compiler. So that's what your segment memory declaration won't be there. That entry point will be there. Start won't be there. Okay. So it will be starting directly from the move instruction. Okay. Even the start won't be there here. So I am going to use it directly from the move instruction. So just first instruction is move R1. I'm initializing my first value R1 comma #10. Okay. So next what is the instruction you should have? So move. So next instruction is move R2 comma #1, because I'm initializing my first number to be pointing to 1. So next I'm initializing my sum. So I'm going to store the value sum in register R3. So I'm initializing my sum to 0. Okay, I'm initializing my sum to 0. So this part is over now. So next, when it comes to the loop, okay, I have to loop it. Okay, loop is the label I'm going to give it for that one. So what instruction I have to use? First I need to add R3 comma R2 comma R3. Okay, so next again I need to add R2 comma #1. So I'm going to increment the contents of my next number. So it will be 1 will be the previous number. I'm going to add 1 plus 1, which will be equal to 2. So next I'm going to subtract sub s R1 comma #1. So it is going to decrement the contents of your counter by 1. Initially the counter will be done. So next it will be equal to 9. So if it is not equal, branch not equal, to where I have to jump? I have to jump to the loop. I have to jump to the loop. Okay. So now, whenever the branch is going to be completed, okay, whenever the branch is going to be completed, so what operation I have to do? I have to halt the program. So I'm going to give the halt branch halt. So this is where it is going to stop the code. Okay. So this is how we are going to write the program. Just I have to run this particular program. So I initialize my number of counts to take. I have to add the first 10 integers. For that one, I'm initializing my counter to 10. The counter will be loaded into the register R1. So I have to start counting from the number 1. So for that one, I want to have the starting number, which is 1. So that number is it is going to be stored in R2. So next, I want the sum of all 10 numbers. So initially, I'm initializing my sum to be the 0. Okay. So next, I'm going to add the contents of your sum with R2, and I'm going to increment to the point to the next number, which is 2. That is 1 plus 1. So then I'm going to decrement the counter. So if it is not 0, if your counter is not 0, I'm going to repeat it. So once the counter becomes 0, it will come out of the loop. Okay, that is what the program does. So once you type it, you just run it. So if you run it, you can see it here. So the value is going to be changing here at the right hand side. Okay. So some mistake has happened. So again, we need to type, I think. So move one comma -10. So just whenever you encounter the problem with the browser, just refresh that particular browser and you start from the beginning. Okay. Move one -10. Next is move R2. All of you are able to see, right? This one, friends.
Yes, sir.
Yeah. If you use it in Keel, it will be better. But we don't have the browser version of the Keel. So if you have the, I will share the software. How many of you installed that particular software in your home? Move R3, comma 0. So I'm going to start with the loop. R3, 2, comma R3. F1. That is right. Yes. R1. One. It is not equal to potential not equal to loop. Then B. Once it is done, so just run it. So initially R0 will be some mistake has been happened. Why it is running? So someone can type in your system and you can check it, right? So type the program in your browser. Okay. So it is R1, R2, R3. So just I will show in the Keel software how it will be running. So if we take this Keel software, sum of 10 numbers, which has been already written here. So I'm going to initialize my 52 R1 to as 10. So R2 to 1, R3. So I'm going to have this particular part. So if you run this particular program, so it will be build target. So once you run this particular part of the code, so debug, start the code. So you can start step by step. So initially the value of R1 will be 10. So you can see it from the figure. So from the contents of the register, so the value of the R1 is 10. Can you observe that one? So instead of 10, it is represented as A. Why it is represented as A?
Hexadecimals.
Yeah, hexadecimal value. So next, the value of contents of R2, the one I am initializing to R2. So you can see it here. So the value of R2 is 1 now. Okay. So next, when you go next, so the value of R3 will be 0. So you can see it here. The value of R3 is 0. So next, it will add the contents of R3 and R2. Okay. R3 value is 0 plus 1. The result will be stored in R3, which is 1 here. Okay. So next, the contents of R2 will be added by 1. So initially the R2 is 1. So when you press next, it will go to 2. So the value of R2 will be going to 2. So next when it goes, so the value, the sum, okay, the subtraction of the counter. Okay. So now the counter is initialized to 9. So you are going to subtract the value of the counter. The counter value is stored in the register R1. So that will be decremented by 1. So now the value of R1 is 9. So this particular process will be continuing. Okay. So this particular process will be continuing till where? Till your counters become 0. That means till your R1 becomes 0. This particular process will be continuing. So you can see it here till R1 becomes 0. So till R1 becomes 0, I will move. So you can see it here. Now you can see it here. The R1 is 1. Okay. In the next step, the R1s become 0. Okay. So the value of R3 is 37 now. So the value of 37 is nothing but what? The hexadecimal equivalent of the decimal number 55. So the hexadecimal value of the number 55 is 37. Okay. So that will be stored in R3. So once it is stored in R3, so this particular statement add. So next I am going to add the contents of R2. It will become 11 now here. You can see it, it will become B now. So I don't want that particular value. I'm going to subtract the counter. So initially the value of R1 is 1. So when you subtract it, it will become 0. So once it becomes 0, you can see in the flags. Okay, you can see the CPSR status here. You can see it here. The zero flag is set to 1 here. All of you can see the red flag what it is setting to 1. Can you observe that one? Can you people observe that one? Anybody else having any answer? Any doubt? Anybody having any doubt? Anybody having any doubt?
No, sir.
Okay. So next, when Z is become 1, so the loop has to terminate there. Okay, the loop has to terminate. So it will come out of that particular loop and the loop will be halted here. Okay, so the final result will be stored in bit register now R3 because I am initializing my sum in R3. So R3, what is the value which is stored in R3? 37. So what is the value we are supposed to get? The sum of first 10 integers, it should be how much? So it should be 55. So the hexadecimal equivalent of 55 is 37. The hexadecimal equivalent of 55 is 37. So you can see it here. So if we take 55, 16 3s are 48, remaining is 7. So the hexadecimal equivalent is 37. So that is the result what you are going to get there. Okay. So now, can anyone tell what is the change I have to do for this next program? So the third program, anybody having any doubt in the second program now? Anybody having any doubt in the second program? Anybody having any doubt in the second program? I'm asking. Should speak, right? It's not a class, it's an online class, right? Even in online class, you are not supposed to, you are hesitating to speak means what? Whether you have understood the second program?
Yes, sir.
Okay. What about the remaining? Nandish? Whether you have understood? Whether you have understood, Nandish? Nandish, Kalyan Keram, Karthik? What about the rest? So now, in the next program, you can see it here. So the next program tells that write a program to find the factorial of a number. Okay, write a program to find the factorial of a number. So now what is the change I have to do for that one? Can anyone tell to modify, if I modify this particular number, if I want to find the factorial of first 5 numbers, for example, what is the modification I have to do for this particular program? Can anyone tell? What's the modification I have to do here? Can anyone tell what is the modification I have to do to your second program to make your third program to work? So in the second program, what we have written, so if you take the second program, so the sum of first integer, so we have started with the program that is area. So area we have defined some code read only. So if I write with the program, so this is your entry point. So I am moving the data. So this will be 10, that is the counter. So this will be R2, which will be your first number. So next is your sum. I'm going to store it in R3. Initially the sum will be 0. So I'm going to have the next label. Okay, so in the next label, I'm going to add the contents of R3, R2, R1. Again, I have to increment to point to the next number, that is R2, R2, #1. Okay, so next I'm going to subtract. Which one I have to going to subtract? It is R1, #0. So if it is not equal, I'm going to have the next. So then I'm going to have one infinite loop, halt B, halt. Okay. So now what's the change I have to do for factorial? So to find the factorial of a given number, factorial of a given number is your third program. So factorial of a given number is a third program. So now if you have the factorial of a given number, so what's the change I have to do now here? Can anyone tell? What's the change? Can anyone tell what is the change I have to do for factorial? So if I am going to have first 10 integers, it will be 1 plus 2 plus 3 plus 4 plus 5, right? Like that I am going to do. So if I am doing the factorial, how I have to do the factorial? If it's the first 5, if I am given to 5 number, so it will be 5 into 4 into 3 into 2 into 1, right? So this is the what the factorial, how we are going to calculate it. Anybody having any doubt? Anybody having any doubt when you are finding the factorial?
No, sir.
Now, what is the change I have to do in the following program? Can anyone tell? I want the answer from your side only. So only small change I have to do. That's it. Where I have to do the change, you have to tell that one. Yeah.
Multiplication.
Sorry. Yeah. You have to use the multiplication. So some code read only. Here it is way fact. You give it the same name. You are going to give fact and read only. Okay. So next is normal entry point. 2 changes you have to do. That's it. So you are going to have the start here. So here also start, you write it if you are using the kill. So then you are going to have the move R1, #5. If I want to find the first 5, factorial of a 5, factorial of 5. If I want to do the factorial of 5, I have to initialize that particular number counter to 5. So if I want to calculate the factorial of 10 numbers, I have to give the number as 10. That is left to you. So that is going to left to the programmer. So this will specify that what factorial you have to find it out. So that is number of counters which you are going to have. So that many factorial number you are going to count it. Okay. So next you are going to have move R2, #1. So again, whether I have to make my sum to 0 or 1 is the next question. Whether I have to make the sum to 0 or initialize my initial fact as what? How much? 1 or 0? I want the answer from your side. If it is a 0,
1.
when you are doing anything multiplied by 0 is how much?
0.
0 only. So that's why we have to initialize your fact to what?
1, sir.
Yeah, you are going to initialize your fact to be 1. So this is one change. So you look into that one. Here, this part, it has to be initialized to 1. So next, here instead of add, what instruction I have to use?
Multiplication.
Yeah.
ME.
So mul R3, R2, R1. Then again it is same. This is add R2, it has to point to the next number. So next, again it is same because it is pointing to the counter. Subtract R1, R1, #1. Okay. So next it will be branch equal to, not equal to, next. And then halt B, halt. So anybody having any doubt? So just look into the program, both the program. What's the change you have to do? So can you write up this particular program now? Both? All of you have taken the program or have to take? So all of you write the program in your book. Okay. So when the college starts, it should be there in your observation book. Anyhow, you are going to keep the observation book, right? So in the observation book, all you write all the first three programs is there. So just take down the program. Anybody having any doubt? Anybody having any doubt? Anybody having any doubt? I'm asking.
No, sir.
Okay. So when you are writing the program, you just see to it that where are the changes you have to do in the program. So that is how your IQ will improve. So you should not do the hard work. You should do the smart work. So you just refer to one program. What are the changes and where are the changes has to be done with respect to that particular program. You have to see it. And with respect to that one, the changes where you have been done, that you look into it and you make that particular changes. So if you understood one program, obviously you can understand other program also. That is like that. Okay. So just take down the program, this one. So just take it down. Once you have completed to take it down, you just inform me. So if you have any doubt there, you just ask me. So I will give 10 minutes of time to take it down. Once you took it, you just inform. Okay. So take it is this will be program 2. Okay. This will be your program 2. This will be your program 3. So only compared to your program 2 and program 3, only at 2 places you have to change the instruction. That is one, you have to initialize your facto 1 initially before entering the loop. Other thing is you have to initialize, instead of adding the first two numbers, you have to multiply it in the factorial. That's it. So you have to make use of the mul instruction. So if you have any doubt, you can ask at any time. If you have a doubt. So once you have the doubt, once you have been written the program with the browser based what I have sent the link, you just type in the code and you execute it and send the snapshot of that one. I will give 10 minutes for that one. You just go through it once. So totally by 12:15, you have to complete both the program and you have to take the snapshot of the both program which you have been completed and you have to send that one to my email ID which I have been given previously. So all of you have to do it. So all of you have to execute this particular program. So I have seen. So just open the browser, type in the code. If any problem encounters, again, you close the browser, open the browser, start with the new link, and you execute it. So once you have took the program, you just inform me. So I will give you 10 minutes to write up, 10 minutes to execute, 10 to 15 minutes to execute. By 12:15, you have to complete both the program. The execution of both the program. So once you have completed, you just inform me. Don't keep silent. Yes. Any question? Any doubt? Anybody having any doubt? So if anybody having any doubt, you just inform me. Or if you are facing any problem while executing, you inform. Just type in like this. Have any problem? So I think the first program you have executed, the same way you execute this particular program also. Once you have typed this particular program, okay, so just run it. Okay. So everybody is everybody is seeing the output. What you are getting? So this is the output what you are going to get now. So just take it, take the snapshot and just send it. Okay. So all of you are getting the output, right? So type in the program in this particular fashion, run it, so you'll get the output. So just after you get the output, you just post it in your group. Post it in the email ID. Okay. Anybody having any doubt? If you have any doubt, you ask. You can see it here one by one. Whatever the register values it is going to change, you can see it here. Okay. Anybody having any doubt? Anybody having any doubt? Okay. So if you have any doubt, you can ask. Anybody having any doubt? So if you have any doubt, you can ask. So execute it and you post it. All of you getting the output like this? Whether all of you are getting the output like this, which have been shared to your group. I shared the output to your group. You can see the values which are there. So you look into that whether everyone is getting like that one. And you run with respect to what are the changes you have to do for your factorial program. Okay. So if you want to write for the factorial program, so what are the changes we have to do? So whenever you are going to type the new program, you type it in a new window. So that is mandatory with respect to this one, I think. So if you reset it, and again if you run it, whether it will run. Okay. It will run. If you reset and if you run, it will run. No problem with that one. Everything is in the middle, we should not terminate. All of you are observing the data which is changing here. Kirtana, Kushi, Arbas, Lekana.
The register values are not changing.
Yeah, it's changing now here. In my system, it's changing, right? In yours, you are not changing.
No, sir.
Yes, sir.
Whether you are able to see in my screen,
Yes, sir.
it is changed. Okay, you just try one more time. Okay, so it will change. Due to some of the limitations of the browser, it may be taking some time. Okay. So otherwise, you open the new window and you just check it out later. But it's changing. Initially, it was also not working with my window. So now it's working. So just you open new window and you just type it. So that's the limitation which you're going to have. So it will take time. So all of you can see my window now for this one. All of your black screen is visible for you people.
Yes, sir.
Yeah. So this is add sum of first 10 number is over now. So just I will show you that how to the changes I have to do with respect to the this one. So I'm going to find the factorial of 5. Okay, factorial of 5 numbers, first 5 numbers. So I'm going to change my wherever the add is there in the first instruction, I'm going to change it as mul. Okay, I'm going to change it as mul. Okay, that I have been done. So remaining thing remains same. So you can see it here from this particular instruction. So it just I am moving the counter because I have to calculate the 5 factorials. 5 numbers will be there. 5 counter is required. So for that one, I am moving it to 5 to the counter. So I'm utilizing my first number to be 1 because if it is 5 factorial, it should be 1 into 2 into 3 into 4 into 5. Like that I will do. So next, I'm going to initialize my initial factorial as 1. I'm going to store my initial factorial as 1. So next, I'm going to make use of the multiply instruction. Multiply the contents of R3 with R3, R2. So initially, next I'm going to increment the contents of R2. So next iteration, your R2 will become 2. So next, again you are subtracting the counter. So counter will become 4 now. So this particular loop will be repeated till the counter becomes 0. So once you run this one, you see the changes here. R1 is 5, R2 is 1. So it's R3 is 1. So R2 is 2, R3 is 3. So then it will become 6. And 6 4 are so able to see that one now. Can you able to see the values of the registers? Students? in my screen? Can you able to see?
Yes, sir.
Okay, just try it out once. Again, you take 5 minutes and try it out. So the same fashion, what I have been executed now, you just look into that one. So the factorial of 5, what it is showing, the answer what it is being shown here is R3. So the result is stored in R3, it is 78. 78 is nothing but what? That 78, why it is giving 78 as the answer? What is the factorial of 120? It is 20, 23 is a 60, 62 is a 120. So if you convert your 120 to your hexadecimal value, so it will be what? 16 sevens are 16. How much you are going to get? It's 6 are 48.
112.
16 sevens are 112, and remaining is 8. Okay. So the hexadecimal value of 120 is what? 78. So the hexadecimal value of 120 is 78. So in the register, what it is going to store? 78 is the value which is going to be stored in your register. So the register, it is going to show, it is going to store the 78 as the value. So just try it out once again. So just complete this tube program today. So it will help you. So anyway, it's working. So those who are having the desktop, one more time you open that particular browser in a new window and you type the program in the which way, in the same way what I have been entered. So you look into the code what I have been posted there. You say I try in the same way. Okay, you try in the same way. So it will work. So just this one also I will post it for your reference. Okay. So this is a factorial of a given number. Okay. So just run that one. Both the program you try it out now and just post it. So it is where if you are finding any difficulty, just do let me inform. It will come. You just go through it once. So if you are not able to get in Chrome, just try it out in Firefox. So even in my Chrome, it was not working. That's why I shifted to Firefox. So in Firefox, it's working fine. So just try it out. I have posted both the programs in your group. Okay. So try in the same fashion. So are you able to get the answer? Just try it out once. You will get it.
Yes, sir.
Yeah, if you have got it, So you just post that one to the my mail ID if you have got the result. So both the program you do it. All the changes I've shown you the changes, right? So those changes you make with respect to the program. So if you have understood the logic, then you don't have to worry about that one. Okay. So if you complete this one, it will complete 3 programs for you of the lab contents. So we will see, because the next programs require kill only, because we have to play with the memories there. So we will, the next class we will complete another 2 programs which is of memory, but you cannot execute that one. Only explanation I can do. That's it. So both the program you type it and you just once you have completed that particular part of the program, you just post it to the mail it to the my mail ID. So this is the interpreter. Some of the codes we are not using here. What are that particular code? That is area. You are not defining the area. We are not having the entry point. That start is also not there. Okay, and the end is also not there. So since it's a web browser based interpreter, so we have certain limitations will be given by them. But when you are doing with a kill, you have the some syntax to be followed. So that you have to keep in your mind when you are doing with respect to the kill. So once you have completed, all of you, just type in your chat box that you have completed that one. The chat box you reply that you have completed. So post it in this particular email ID.
Completed, sir.
So just you post it in this one. So remaining, whatever the rest, complete at the earliest. So if you have any doubt, you just ask your friends who have completed. So those who are completed can leave the meeting if they wish. Okay. So remaining who have not completed, complete at the earliest. You have to send So once you are completed, you can leave the session.